Welcome to a new episode in the Multiverse video series. Today we're going to learn how to use Apache Arrow with Spark using R. So first of all, what is Apache Arrow? Well, Apache Arrow is an Apache project. This means that it's an open source project that, just to be very specific here, you can go to the Apache Arrow website at arrow.apache.org, and you can see a quick definition here, which says Apache Arrow is a cross-language development platform for in-memory data. It is fast, flexible, and standard. Now, if you want to understand why Apache Arrow is useful in Spark, I think the concept that you need to notice is what's the advantage of using Apache Arrow when it's stored in memory. So the interesting thing about Apache Arrow, and in general, if you take a look at how processors work, processors are pretty good at executing vectorized operations over subsequent integers. So they're pretty great at, for instance, in this example, we have a session ID and all the data types are the same, are just integers. And then you have timestamps. So when you send instructions to the CPU, like add all these numbers, it's actually much more efficient to have sequential types for the CPU to process these particular operations than to have, for instance, what we have on the left column is asking the CPU to process first an integer, then a date time, and then perhaps like a floating point number, or an IP in this case. Anyway, so this is at the CPU level. Whenever you send a batch, or if you call it a vector of different operations, like the CPU is much more efficient. And one of the benefits of using Apache Arrow is that the way that the Arrow format establishes this particular layout of memory is precisely that. It's what it's called columnar, which, by the way, R also encourages when using data frames. So data is stored by column, not by row, which is the example that we have on the left. And the other advantage of using Arrow, which especially if you're familiar with Spark, this is a problem that you will be familiar with, which is, in a lot of times if you have one system, just Spark, everything would be great and, easy. You only have Spark, everything is in Spark, and why not, right? But a lot of times, if you're using Spark with Python, you might have to be converting from Spark to Python, right? If you have the Parquet file format, which is a pretty popular format supported by Spark, you may actually have to convert between Spark and Parquet. If you have databases, or why not, you might have to be transforming that. If you're also using R, there's another conversion of data types going between Spark and R, and why not? So it definitely, you can end up pretty easily when you have more than, 3 systems, or even with 3 systems, you basically end up having to copy and convert data types and structures between different systems. So the idea behind Arrow is that that you can use Arrow as a single memory store, that different systems and programming languages don't need to convert data across them. That's the main idea. So how is this interesting for Spark and R? Well, today we're gonna take a look at one particular function that takes advantage of Arrow, which is Spark apply. So what this function does is it basically allows you to apply a custom transformation in R code for any Spark data frame. And the challenge here is that when you use Spark apply, the way that is represented is as follows. So whenever there's data in Spark, it is common to have it stored per row. And, for a simple example, this would look like this: A, 1, 10. You have this data set. And, like the next row would be B2, 20. All right, so when you transform this in Spark with Spark apply, a few things need to happen. So first of all, R is a columnar, um, encourage columnar storage in data frames. So the first thing that needs to happen, well, actually, even before that, the very first thing that needs to happen is just transforming the rows in Spark to rows in R. And even though they're the same, it's an integer and it's a character, things are stored slightly different in different programming languages. So you still need to transform this row to the row on the right, and that takes cost. So that's the first time that you hit this transformation cost. The second time is when you transform this row a, 1, 10, to an R data frame, which is basically stored by column. So you would have to transform each particular row to a columnar store, which would contain the first column would contain A, B, C, and then 1, 2, 3, and etc. So just getting the data from Spark to R in columnar format would take 2 transformations. And then once you applied your custom transformation in R with Spark apply, you would actually have to transform it back from columnar to row, and then send it back to Spark, which again incurs another transformation. So the way it works with Arrow is as follows. You can just say you have Spark and Scala, and basically with Scala would make the transformation for you. So you can just basically say, ask Spark to transform the data from row format to columnar format in parallel at scale. So this is pretty, it's a much faster operation because it's parallelized, and it basically gets transformed to columnar format. You might also be able to reduce this step if you're using formats like Apache Arrow, which are already columnar. And then basically you transform that columnar format. All you need to do, or all we need to do for you, is basically pass that data from Spark into R, and the data is already in columnar format, so there's no transformation whatsoever that happens between Spark and Arrow when using Arrow. That's pretty much it, and it makes things really, really fast, and that's what we're gonna look in this video. So the first thing that you want to do is you want to say install packages Arrow, and this is basically going to install the Arrow package in Windows and in OS X. Basically, it is pretty straightforward. You just need to run install packages Arrow. In Linux, you would have to install the Arrow runtime yourself. So this means that if you're using a proper cluster, you would have to install Arrow across your cluster on your own. But for this particular example, or while using a local connection, all you need to do is basically install Arrow. And then we can look at 2 examples. We can, first we're going to connect with a local connection. And once we're connected, we're just going to try to use Spark apply, which I like using this function sdflen, which all it does, it gives you an array of numbers. It's similar to the length function in R. Anyway, so we have a length of we just have a small array of numbers, and then what we can do is apply a custom R transformation. So in this case, we're going to copy the number. We're going to count the number of rows. That's all we're going to do. So we're counting the number of rows, right? And we'll do one video perhaps about explaining in detail Spark apply, but the topic of this video is going to be Arrow, so just follow along with this. Right, so we have, we're counting the number of rows using a custom transformation, and then we can also time how long this takes. And to make this meaningful, we're gonna do just 1,000 rows, and we're gonna collect the results to make sure that this executes. So basically what is happening under the covers is we are sending this transformation to from R to Spark, and then Spark is parallelizing, and then once it's parallelized, we're basically executing this transformation over each node. So that's how long it takes. We can make it a little bit longer by doing 10,000 elements. And we're just going to take a look at how long this takes using plain R. So this took 8 seconds, which is pretty slow for just 10,000 rows. So what you want to do now is you want to include a library Arrow. And whenever the Arrow library, there's no package called Arrow. Okay, so I haven't installed Arrow apparently here. So you get to see how to install Arrow. So let's disconnect. And we're going to install Arrow really fast. Might not be that fast, but doesn't take more than a few minutes. So while this installs, what I'm going to show is basically a couple of things. One is that Arrow is already on CRAN. So you can basically go to the website, and I believe it was published August 8, 2009. And yeah, so from now on, you can basically just install it directly with install packages, which is, it's pretty handy. And yeah, and the other great resource to know is if you go to the Apache Arrow website directly, which is on GitHub. This is a quite large project, so there, if you're focusing on R, you definitely want to just go directly to the R folder. And here you can find a few additional information nuggets that you might want to read through. So, you know, as we were mentioning, Arrow is available on CRAN, so you can just say install packages Arrow. But you can also use Conda users if you prefer from Linux. And in Linux, what you would want to do is install Arrow, which you know, will give you additional information of exactly what you want to install after and before and after you get the Arrow libraries and the Arrow package working. So this is still installing, which is interesting. This is just downloading from CRAN, so it shouldn't take that long. It might be the case that since I'm recording, it's basically gonna take a little bit longer. But yeah, that's pretty much it. Let's make sure that it actually works. Yeah, so now we have the Arrow package loaded. All right, so let's try this again. We're gonna rerun the exact same example. So we're connecting, and then we're gonna basically execute the previous comment that took us about, you can see here, it took about 8 seconds, which is very, very slow. So we're gonna rerun it now with Arrow. And even more interesting than this, what we want to do is, yeah, it took 4 seconds, but it's, you know, the first time it's always, things are a little bit slower and there's overhead. So it's kind of like half the time. But it's there's actually, you know, it's actually more interesting the more data you use, because basically the overhead is much more lower. So we can actually do this with 1 million records. And even with 1 million records, it's pretty fast. So it's still 3 seconds. And again, part of this is the overhead of just launching Spark job, and why not? So it's not very relevant, you know, like to run this calculation for small numbers. But you can see here that it's already significantly faster than Arrow. So in Arrow, you know, we were doing 10,000 rows, and without Arrow, we were doing 10,000 rows. And with Spark and Arrow, we're handling 1 million rows in 3 seconds, which is pretty fast. We can even go a bit further. And this particular connection doesn't have a lot of memory, so we might hit an error, and we might have to increase memory. But in general, you know, it's pretty fast. So we can do basically on those 7 seconds, we can do 10 million rows compared to 10,000 rows, which is, it's pretty insane. So definitely, I think the caveat of this video is definitely try your best to use the Arrow package when you're using Spark Apply. When you're not using Spark Apply in Spark, like honestly, the benefits are much smaller from using Arrow. There's definitely a few improvements when you're copying data and when you're collecting data, but Arrow definitely shines when using Spark Apply in Spark. If you're wondering, you know, how to disable Arrow when using Spark, all you need to do is detach the library. So if we were to execute again, I'm not going to do it for that many records, but if we do it again if we do it now for only 10,000 records, you can see that it's going to take a while. And again, to activate Arrow again, all you need to do is reattach the library and re-execute, and you're back in business. All right, well, thank you so much for watching this video. I hope it was useful, and we'll keep in touch.